Hello students, welcome back. Let's begin the regression problems. We are talking about problem 1C and 1D. These two problems, by the way, 1C and 1D. However, these two problems are related to this data set, so let's begin all the way from the start. The following data table shows the daily high temperatures of Houston, the daily low temperatures of Houston, the daily high temperatures of Dallas, and the daily low temperatures of Dallas for the month of May 2020. And we have a long data set here, and then we have mean and standard deviations. Now, the main body of this data set, those are important for problems 1A and 1B. For 1C and 1D, we only need mean and the standard deviations. Why? That's because we have this regression formula we want to get best point estimation y hat, and that's obtained by r sy over sx times x minus x bar plus y bar. Now, if you prefer to use another method, textbook's method, then I'm not gonna stop you from doing that, but please be warned, it's gonna be messy. It goes kind of like this. Break up this parenthesis, alright, by distributing this to both x and x bar. This is what you're gonna get. Okay, do you see this? From here, distribute this one to x and also x bar. We get that. Okay, and then we're gonna name B1 as this quantity, and then let's see, B0 as this quantity, y bar minus this. But then again, this quantity is called B1, isn't it? And this can be rewritten as now B1, and then this is same as B0, and I can change the order of addition. I mean, this was B1, and this whole thing is now B0, and my manipulation is complete. So if you know what you're doing, you can use this. But for the overwhelming majority of the students, you probably didn't like what I just did. I suggest this. And for the rest of this video, I'm going to use this one alone. If you're really insisting this, from that point on, I'll just leave you with my MATLAB and other sources. So no more of this now, and then let's do it this way. Okay, let's go to problem number 1.3. Find the best point estimate of Houston's high temperature. So that's my y. If the high temperature of Dallas is 80 degrees, so Dallas high is something we know, so we are talking about this. X is Dallas high, y is Houston high, All right. And then we are using this formula, of course. And then, okay, let's move these over here because we are doing 1.3. We're not doing 1.4 for the time being. Okay, all right. Okay, we are doing this. Okay, from here, Dallas High is known as 80 degrees. So let's copy and paste this thing now. This is regression formula. Now we are doing actual computation. So everything is approximate from this point on. And Dallas High now is 80 degrees. Where do I put in 80? X is 80. Okay, all right. So we got Dallas is 80. Okay, this is regression formula. And Dallas is X and Houston is Y. So Dallas is 80.0. Okay, all right. Now, X bar, bar means mean. But is it Dallas or Houston? What's X and what's Y? X bar, so it's Dallas. So let's go to my data set and let's find out the mean for Dallas High. Dallas High, right here. 84.48 something. That's for Dallas. Now, how about Y bar? Bar means mean, and is it Dallas or Houston? Y is Houston, so we have to go to Houston. Houston I is over here. Okay. Now we want standard deviation Sx and Sy. Sx. Is it Dallas High or Houston High? X is Dallas, so we want to go to Dallas. So let's go to the data set, standard deviation for Dallas. So that. And then this is for Houston. Standard deviation for Houston High. So there you go. And then what's the correlation coefficient? I think the problem explicitly gave you that. Let's see. Yes, it gave you this. So no problem there, just plug it in. And that's it. I think font is too big. Okay, that's large enough. So I'm using this formula here. Red is correlation coefficient, and I'm using blue for y's and green for x's. And then that too is x. And then how do you calculate this thing? I have calculator with me here, so let me use Mathematica. I could have used any other calculator, but this is as good as any. Oh, excuse me, a typo here. I ended up using colon in place of dot. I don't know why I did that. 84.395 approximately speaking. There you go. Or approximately even further, 84.4 degrees. So do you see the formula? And then what to put where? Bars are means, so you have to look up means, and S's are standard deviations, so you have to look up the standard deviation. And what's x and what's y? Known is x and unknown is y. And put all those numbers in from the data table and run your computation, and that's about it. Let's do this one more time. Find the best point estimate of Dallas low temperature if the low temperature of Houston in the same day was 65.0 degrees. So what's known and what's unknown? Known temperature is Houston. Dallas low is unknown, and that's what we want to find out. Okay, all right. Same formula here, and that's too large. Let's begin with R, the correlation coefficient. Problem must have given it. Yet, it's given. The problem gave you that explicitly. 0.75 something, and that goes over here. And then let's go to SY, the standard deviation, but is it Dallas or Houston? Y is unknown, so Y is Dallas. Okay, let's go to the table. And we want to look for standard deviation, but we want Dallas low. Yes, Dallas low. That goes here. And then standard deviation for Houston low. Standard deviation for Houston low. And then Houston current temperature 65.0, and then Houston average. Bar means average. So Houston mean, is this Houston? Okay, Houston mean 69 point something. And then Dallas mean let's finish our computation. Oh, I guess this colon versus decimal point is coming from the copying and pasting. Okay, anyway, this is what I got, 61.95 something. So approximately speaking, this is 62.0 degrees. Or any kind of reasonable estimation, I'll take it. Anyway, formula is there, and everybody must prepare this. This is slope point equation of the line, and the regression line, of course, run through the average point, x bar comma y bar. And then the slope, you obtain the slope by r sy over sx. So this is the slope point equation of the line, and all you need to do is to plug in appropriate numbers here in the data table. Now, which is which? That's going to be your job. You see, what's x and what's y, and what is the quantity you want to know, what is the quantity you know. That's how you make decision. By the way, let me show you a picture. And that was for regression line for Dallas High and Houston High. And yeah, okay. I don't know how helpful this visualization is. Anyway, here we go.